Hi, everyone. Welcome to TISCU. I'm Genevieve, and today I'll be tutoring you on project management and control. So, first off, what is a project? A project consists of interrelated activities that are meant to be executed in a certain order, particularly a sequence, before the task is completed. Now, since projects are meant to be executed sequentially, it will now bring about the precedence relationship, which is what we'll be talking about in this tutorial. Now, the precedence relationship just states that before another activity starts, one has to be completely done. That is why a project must always have a definite starting and ending point because they are interrelated and they are in a sequence. So one activity must be completed before another one starts. Now, since we know that projects are in precedence relationship, how do we identify this precedence relationship? So they're represented diagrammatically using a network. And there are two types of representation using the network. We have activities on arrows, abbreviated to AOA, and activities on nodes. But for this context, we're going to be using activities on arrows. For this tutorial, there are some common terminologies that I have to explain. One includes activities. Activities are tasks to be performed and they'll be represented using the arrows. Then we have the nodes. The nodes will represent the starting and ending points of an activity. Then the network itself, that is the graphical representation, would contain the graphical display of all activities and events in their relationship in specified precedence order. Then another important terminology is the slack. The slack represents an excess period that exists between the latest starting time and the earliest starting time. So the slack is calculated as the latest starting time minus the earliest starting time. Then the dummy activity. The dummy activity indicates a precedence relation that doesn't require any time or effort. It's just a figurehead. Now, let's go to project management techniques. We have three project management techniques. We have the Gantt chart, we have the critical path method, abbreviated to CPM, and we have the project evaluation and review technique, PERT. So the second technique is critical path method, and this helps to identify critical activities that must be continuously monitored. So the critical path is usually the longest time that it takes to complete a project. And the critical path is also a path with no slack time. That is, the earliest start time equals to the latest start time. And I will explain it more using an example. Using this example, from this table, we have the activities, we have the precedence activities, and then we have times in week. To solve this question, we need to draw a network diagram. So we're starting with the network diagram, and we're starting with the starting point, which is, then we have A, then we have B, then we have C, then we have D, we have E, we have F, then A, we have G, for G and F precedes H. So I can come here, erase this one, and come here.
Just here. G. A. This is H, and this is I, and that's the finish. And then we have your network diagram.
And note for the network diagram, it's advisable to use your ruler. But for this tutorial, I have tried to use my hand. But like when you're drawing the activities on arrow, it's best to use your ruler and show the arrow to show the activity preceding.
And then since we're doing the critical path method, we need the activities. So I have to write the preceding the activities, the duration for each week. A is 4 weeks, B is 3 weeks, C is 2 weeks, D is 4 weeks, E is 1 week, F is 4 weeks, G is 6 weeks, H is 4 weeks, and I is 3 weeks. Now, for your critical parts, to find your critical parts, I said that the earliest starting time must be equal to the latest starting time. So you come here and you do your ES and your LS. It just starts and it's 0. Then 0 plus 4 is 4. Then 4 plus 3 is 7. 4 plus 2 is 6. Now, D and E precedes F. So 7 plus 4 is 11. 6 plus 1 is 7. So you are going to use the highest one, which is 11. And you come here, 4 plus 6 is 10. But if you come here, F precedes H, so 4 plus 6 is 10. You just keep that in mind. 11 plus 4 is 15. So 15 is higher. So when you're doing your forward computation, you use the one that is higher. That is when you're finding your earliest starting time, which is 15 instead of 10. 15 plus 4 is 19. 19 plus 3 is 22. Then that means this is ES and LS. That means your earliest starting time is 22. The backward, 22 minus 3 is 19. 19 minus 4 is 15. Then you come here, 15 minus 6 is 9, but just keep it in your mind. 4 minus 15 is 11. 4, and then you now have 11 minus 1, this is 10. 11 minus 4 is 7. Then 10 minus 2 is 8, but 4 minus 7 minus 3 is 4. So for your latest starting time, you are subtracting and finding the one that is lower. So since 4 minus 3, since 7 minus 3 is 4, and also on the same part, 10 minus 2 is 8. Remember, 15 minus 6 is 9, but they all draw to this part. So between 4 9 and 4 8 and 4, 8, and 9. The lowest one is 4. That is why I picked 4. Now, when you have done that calculation, you're going to pick the parts. So you're going to pick the parts which you're going to pick the like possible parts in which the critical part can be. So the critical part can be A, B, so D, so F, so H, so I, or it can be from A to C to H to I, or it can be from A to G to H to I. But remember, the critical part is always the longest part. So that means this one has been discredited because between these three, the last one is kind of the shortest one. So we are not using it because the conditions for a critical part is that it must be the longest part and there must be no slack time. Using the diagram, we can find our critical part by looking at the one where there's no slack time. That is where ES equals to LS. So you identify your critical part using double lines. There's no slack time here. 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 So your critical part is A, B, D, F, D, F, H, I, which is this one. So this one is discredited because ES is not equal to LS, because if you are looking from the diagram from A to C, C is 6 and 10, which already discredits C, A, C, E, F, H, I being the critical part. So you come here and you're like, critical part, F plus H plus I, 4 plus 4 plus 3, and that is 22 weeks. The third technique we're going to look at is project evaluation and review technique, PERT. PERT analyzes the task by emphasizing on the uncertainty and the variability in task duration. That means it's saying that a task might not always have like a standard time, unlike critical path method where we're like, oh, it's 4 weeks and it's 4 weeks. You're like, let's take into consideration the uncertainty in the task duration. So it uses the probabilistic beta distribution, which will be explained better in this tutorial, where you have your three-time estimate. Your three-time estimate, which consists of the optimistic time, the most likely time, and the pessimistic time. The optimistic time is represented as A. So A equals to the optimistic time, because remember I said that like we use the probabilistic distribution which of a three-time estimate. So A equals to the will be represented as the optimistic time. M represents the most likely time. And B represents the pessimistic time. So how does this work? So using A, B, A, M, and B, we're going to use A, M, and B to calculate the mean. The mean represented using this symbol is calculated as A plus 4m plus B all over 6. Then your variance, which is represented using this symbol, is B minus A all over 6. And your standard deviation is usually your square root or variance, which is B minus A over 6. So now I'm about to solve a question using this. So from the table we're given, we have our activities. We have our activity. We have your A, B, C, D, E. And we are giving the predecessor. Okay, so from the question, yeah, we are asked to solve to find the critical paths to draw the network diagram. But to draw the network diagram, we need the mean because the values we get from the mean will serve as our estimated activities because we have 3 time estimates. So we want to get like an actual figure, just one. So we'll start by solving the mean. And the mean, I'll just solve for like 3 activities, then you can solve for the rest. And then you can confirm your values with the image we displayed on the screen. Mean, as I explained before, is A plus 4m plus B over 6. And for for activity A, the A was 6, the M was 4, 7, M was 7, and the B was 8, which is divided by 6. And that will give us 7. So we can go the step further to find variance because they asked us to find variance, right? Variance is B minus A over 6, which is equals to 8 minus all squared, which is 2 over 6 all squared, and that is equals to 1 over 3 all squared, which is 1 over 9. We can solve for B. B would be mean equals to 1, which was given in the question, and over 6, which is 3. And the variance is 9 minus 1 over 6, which is 8 over 6 raised to power 2, which is 4 over 3 raised to power 2, which is 16 over 9. And for C, we have mean, where A is 1, 4 plus 7, and your is 6. So the other values will be given in an image. So we can draw the critical paths using the values that we are given. And we start with our starting point. Our starting point is a node. Then there are 3 activities that do not have a predecessor, which is A, B, and C. So this is A, B, and the values were given as the mean values we got were 7, we got 3, we got 4 and C. Then D precedes A, so we can have D. E precedes A and B, so you can also have E. Then C precedes F, C precedes G, then H H precedes sorry H precedes E and F, so we can have H, and we can have I precedes E and F too, so we can also have I here. And the next one is J. J precedes D and H, so we can decide to extend the line for D. Note, please try to use ruler when you're drawing in exam conditions. And so we can come here and have your note that when you're drawing a network diagram, it is an offense for you to have an empty node. It is an offense for you to have an empty node. That means a node that is not connecting anything, like it's just alone standing on the air. Now remember before we started drawing the critical part, we got before we started looking for the critical part, we got the mean for some, and the other ones were solved before the tutorial. So we just input the mean values, and for D it is 2, this is 3, this is 5, this is 3, this starts from 0. There are 2 activities preceding this node, 7 and 3, and the earliest starting time, we always start with the highest. We always pick the highest. So between 3 and 7, the highest is 7. Then you come here, 7 to 2, but you just keep it. You have 9, 7 plus 2, 9. Just keep it. Then you come here, B to 7 to 3. 7 to 3 is 10, but still keep it. Just come here. This precedes the C precedes this node. So 0 plus 4 is 4. We have 4 plus 5. 4 plus 5 is 9. 4 plus 5 is 9. 7 plus 3 is 10. 7 plus 3 is 10. So we can either have 4 plus 9 and 7 plus 3. So we're picking the highest, which is 10. 10 plus 4. 10 plus 4 equals to 14. And we have 7 plus 2, which is 9. So between this and this, 14 is the highest. So we're picking 14 rather than 9. 14 plus 6 is 20. If we come here, this is 5 and 4 plus 3. We can either have 4 plus 3, which is 7, or we can have 10 plus 5, which is 15. So here will be 15. 15 plus 3 is 18. 18 is lower than 15 plus 3 is 18. And 18 is lower than 20, so we're picking 20 because it's the highest. Then we now have the ES and we have the LS. This is 20. 20 minus 3 will give us 18. 20 minus 14, 20 minus 6 will give us 14. That one is good. Then we come here, there are two nodes. We have 15 minus, we have 18 minus 5. We have 18 minus 5, which is 13. And we have 14 minus 4, which is 10. You're picking the lower one when you're looking for the earliest starting time. And the lower one between two is 10. Between two of them is 10. So you pick the 10 and you ignore the 13. You come here too. You have you have two nodes. From you have from H to E and from H to F. That's backward. Then you have 10 minus 5, which is 5. And you have 10 minus 3, which is 7, which is good. We are good with that one. Then you have three things to pick from. You have 7 7 minus 3, minus 7, which is 0. You have 7 minus 3, which is 4. And you have 5 minus 4, which is 1. And between 0, 4, and 1, the lowest is 0, so you put 0. Now remember that critical path is always where your ES equals to your LS. So we can identify critical path here using double line. Here is equal, here is equal, here is equal, here is equal. Now, to identify your critical path, we are picking the longest path. And the paths that you can identify in this question are, you can do A, B, J. You can go from A to E to H to J. You can go from B to E to H to J. And you can go from C to F to I to K. You can go from C to G to K. The longest part, the shortest parts will be eliminated. This will be eliminated. This will be eliminated. So there are three long parts, and you now look for the one with no slack time. And the one with no slack time is A, E, H, and J. That is why this is our critical part. Now that we have identified that A, E, H to J is our critical path, we can find the project duration by adding the sum of their means together. So therefore, project duration will be A plus E plus H plus J, which is equals to 7 plus 3 plus 4 plus 6, which is equals to 20 weeks. Now, to get the variance was already calculated and the results were shown in the image provided. The variance is A plus E plus H plus J, which is equals to 9 plus 1 over 9 plus 16 over 9 plus 0 plus 4, which is equals to 58.5 weeks. Therefore, standard deviation, which we're going to abbreviate in this tutorial to SD, is square root of variance, which is 5.89 weeks, which is 2.43 weeks. Now, in the question, they said, what's the probability of finishing on time? Probability of finishing on time will be represented as P because the time in the question, the product duration in the question was 20 weeks. So what the probability of finishing all of before 20 weeks is x greater or less than 20, where p equals to x. Okay, now the entire thing here will be written as, the entire thing here can be written as z. That means when we're solving the question, after we get the arithmetic values for this, when we're solving the questions, we are going to use the z table to get the probabilistic value, which is, then what is t in the question? T in the question is the amount that they gave you to find. Like, for example, they said, what's the probability of finishing on time? The probability of finishing on time in this question is 20 weeks because that's the project duration. So your T is always going to be what's there and the probability of what they're asking you to find. P equals to Z, which is 20 minus 20 minus, then mean into bracket c. Mean into bracket c is telling us what is the what is the mean of the, you know, the mean was what we use to calculate our critical path. So it's like what is the actual product duration after doing the probabilistic per term distribution, which is also 20 over your standard deviation. But remember, we calculated the standard deviation for this question using the critical part, and the standard deviation we calculated was 3.4. So we come here, p equals to sorry, 0 divided by anything is always 0. So z is greater or less than 0, so it's less or equals to 0. Then you go to your z table. Under 0, your z table under 0 is giving equals to 0.500, but is in p, so you convert it to percentage, which is 50%. So therefore you write, when you're answering a question, you write the probability of the project finishing on time is 50%. For the second question, we are asked the probability of finishing on or before 25 weeks, which is p greater or less than 25, which is equals to p z. And in this question, remember I told you that t is just what we're asked to solve. In this question, it was on or before 25 weeks, so it's 25 that will be at t, unlike the previous one. But the u will still be the variance of the question, which was normally 20, and the standard deviation will still be this sum of the critical parts, which was 2.43. And p equals to 0.9803, which is approximately 98%. So to answer the question, it will be the probability of finishing on or before 25 weeks is 98%.